Eric Burgess here. A random sample of state gasoline taxes in cents is shown here for 10 states. Use the data to estimate the true population mean gas tax with 99% confidence. Does your interval contain the national average of 43.7 cents? Alright, so we have some data here. Now there's two ways to do this. We could do this by hand, or we could do this using the calculator. Let's do the calculator way first, and then we'll also do it by hand. And let's just dive right into this. Alright, so both ways are going to require us to put the list inside of the calculator because we will be using in both ways the 1var stats to get the mean and the standard deviation, whatever other kind of stuff we need. I'm not going to be doing that stuff by hand. There are formulas for that, but for this problem, I'm going to go ahead and use this for both ways, just so you're aware. So come into edit, you hit stat, go to edit, and we're going to come in here and put it in our first list. So I'm going to clear it because I have stuff in mind. So you highlight list 1, hit clear, and then push down, and it should clear it. And we're going to go ahead and put these numbers in. So we've got 39, 41, 68, 32, 51, 38.1, 43.5, 50.8, 35.3, and 39.2. And it's a good idea to just go through, double check, make sure the numbers you put in are the numbers that you meant to. No mistakes were made. It can save you a lot of headache. Okay, cool. So list 1, we've got them all in there, and we've got how many numbers? 10 numbers. 1, 2, 3, 4, 5. So we've got 10. All right, so what we need to do now is we're going to go to stat, over to tests, and we're going to come, and we need to decide what are we using here. So we've got here some data, but we weren't given a standard deviation, much less a population standard deviation. So that means we're going to have to compute a sample standard deviation, which indicates that we will be using a t-interval test. So we already know it's going to be a t-interval because we are going to have a sample standard deviation. All right, now coming in here, we're going to go to a t-interval because that's what we are going to be dealing with. So we are going to choose option 8 under the tests and the stat menus. And in here, we're going to choose data since we were given data. We're going to use list 1, frequency 1, and then our confidence level. We want to be 99% confident, so we're going to choose 0.99, and we're going to hit calculate. It's going to compute, and we are given the interval. So the interval for the true mean for gas tax is between 33.1 and 54.5. for the 99% confidence. So if you wanted to write a sentence, you could write a sentence that says you are 99% confident that the what are we looking for? That the state gasoline taxes, the true mean of the state gasoline taxes is between 33.1 cents and 54.5 cents. And you would also say that yes, the national average of 43.7 cents is in our interval because 43.7 is between 33.1 and 54.5. And so that's all we would say here. And then you'd be done. So you'd write out that big long sentence and you'd be done. Now there's another way to do this that your teacher may require, and that is to do it by hand. So the formula for that is going to be our point estimate, which is going to be the mean, and then plus or minus some error, right? We're going to have an error below the true mean and an error above the true mean. And so that error we characterize by the distribution. We're using a t-distribution. So it's going to be t of alpha over 2. Now you might just look at your sheet and see what it is. And it's going to be s divided by the square root of n. And then less than the mean. And then we're going to have on the other side our point estimate. Oh, this side should be minus. It's going to be, because that's going to be the less than the mean side. And then this side's going to have the plus t of alpha over 2. Because this side has the greater than the mean side. All right, so we got to figure out what our alpha over 2 is. Our confidence level is 99%, which leaves us with an alpha of 0.01. So half of 0.01 is going to be equal to 0.005. And I like to double check just to make sure I didn't screw up any mental math. and just verify. Trust me, it can be worth a little extra confidence, especially on an exam. All right, so now that we have that, all we need to do is look this value up in the chart, or you can use the inverse calculator option. So in the calculator, you can actually go to the distribution menu, second distribution, and we want to do an inverse t lookup to find the t-score that we need. So if we do an inverse t, it's going to ask us for the area. Our area is 0.005, 0.005. Our degree of freedom is one less than the number of values. So we have 10 values. So one less than that's going to be 9. And that's it. That's all it wants. We hit enter, let it think, and it gives us a t-score. So our t of alpha over 2 is equal to plus or minus. I know it says minus, but the distribution is symmetric. So you can take the positive version as well. And we get this value. Now let's go ahead, let's get this in the chart as well, just to show you the other way. So we just need to look up in the t-distribution chart this value. So we're looking for 0.005. And remember, this is a confidence interval, which means there's going to be some alpha on the left and some alpha on the right. And so that's going to make this two-tailed. So we're going to look for two tails. They're going to contain a total area of 0.01. And in one of the tails, they'll have an area of 0.005. So if we come over to the t-table and we look here, in two tails, we're looking for 0.01. So here's the two tail that has 0.01. And in one of the tails, we have 0.005. So this is the one that we want. So I'm going to highlight these. And then if we look at this, we have a degree of freedom of 9. So there's our degrees of freedom. And we're just going to come across here like this. And on this chart, we get a t-score of 3.25. So let's go ahead, let's compare that with what we have. And look at that. 3.25, the exact same value. So you can use either method. You may get a value that slightly differs depending on, rounding and things like that. But they're going to be very close. So that's how you do it, finding both ways. Now we can plug this stuff in, but we're missing a couple things. We were given data, and because of that, we don't know the sample mean yet because we haven't computed it, and we don't know the standard deviation. So there are formulas for both of these things, and by all means, you could use the formulas. But in this case, I highly recommend just putting it in the calculator and letting the calculator do this for you, because it's pretty easy to accidentally type something in wrong. It's very repetitive, especially computing the standard deviation. So if you've put them in the list already, you can go to stat, calculate in one variable statistics, give it list 1 because that's the list we put it in, and leave frequency list blank and hit calculate, and it's going to compute it for us. So we get 43.79, and our S we get is 10.4, and if we round it 2 places, 5. It may actually be recommended to work with a few more decimals for accuracy and round down later. But this is fine for now. So, okay, this is what we have. Let's go ahead and plug all these values in, shall we? So we're going to get 43.79, that's our mean, minus our t-score, which is 3.25, times the standard deviation, 10.45, divided by the square root of n, which is 10. And then on the other side, we're going to have the same thing, 43.79, but it's going to be plus 3.25 times 10.45 divided by the square root of 10. That's the only difference. And I skipped a middle step here, right? The mean is in the middle. There's a mean, and it's in the middle of these two things. So, okay, with this formula, we should get the same interval as we did up here. We expect these numbers. So let's go ahead, let's plug this in the calculator. So we're going to come in, we're going to do 43.79 and minus 3.25 parentheses. And then I'm going to type it the old school way just because it works on more calculators. 10.45. And then we're going to do a division. Now put another set of parentheses just to be really clear. And we're going to do a square root, second square root 10. Come out from underneath it, close the parentheses for the bottom. So we're guaranteeing that this bottom portion happens first. And then we're going to close the parentheses for the division itself. So, okay, we've done this half. If we hit enter, look at that. We get the exact same thing. 33.1 when rounded, 33.1 when rounded. If yours, if you have some other value that's somehow rounded differently, then, well, first off, then you probably entered different numbers than me. You should get this exactly pretty much. But if you get something really close, maybe your value for your t of alpha over 2 is slightly different. As long as it's really, really close, you're fine. So, okay, we're going to now to do the other side, we're just going to come up and copy this. You just highlight it and hit enter. And then we are just going to come over here and change that minus sign to a plus. It's the only thing that's different. And we get 54.53. And over here, see, we get 54.5 because we just rounded to one spot. And so this would again be our answer. And if your teacher wants you to, you should write out the statement of what this means. So this would be the interval for 99% confident, but you are 99% confident that the state gasoline taxes in cents is the national average is between 33.1 cents, 54.5 cents. And you notice that, yes, 43.7 cents is in the interval, And that's all you got to do for this one. If you have any questions about this, let me know, subscribe, and we will catch you in the next problem.